How are you being asked to explain the hows and whys of the math? And when are you building on what you already know? But keep in mind that as soon as this lesson is over, you're going to put your PST hat back on, and we're going to debrief it in a deeper way, talking about how you can support fellows in doing this type of thing. So you're just a student for now, but don't forget about being a grown-up. Ready?
Alright, I think we're small enough group where, for like teacher-student purposes, I'll just do a countdown just to pull us back together. And I'm gonna run it like a real classroom. And it's like, okay, great, I can see everyone's name tag. I'm really sorry if I pronounced your name wrong or something incorrectly. I just wanna like see what.
Do you want my cheat sheet of everyone's names?
Yeah, absolutely.
It's very handy.
Great. Beautiful. Oh, this is like whole call perfect. Okay. All right. Good evening, my beautiful 8th graders. Today we are starting a new lesson that is going to focus on understanding and interpreting slope within linear equations. You guys did a fantastic job this morning allowing me to gauge your prior knowledge with linear equations, but today we're going to push that knowledge forward in terms of proportional relationships. First, can I please have a reader to read our lesson target of today, please? Michael.
Students will be able to graph a proportional relationship to demonstrate infinite solutions of two variables and determine the unit rate, integer and fractional from that graph.
That was really fantastic, fluent reading there, Michael, but this time we'd like you to read it through one more time, and all scholars should have their pens in their hand, and as Michael is reading the lesson target, I'd like you to go through and circle words that you are already familiar with. You're circling words that you're already familiar with. Thanks, Michael.
Okay. Students will be able to graph a proportional relationship to demonstrate infinite solutions of two variables and determine the unit rate, integer, and fractional from that graph.
I see circling of proportional. I see circling of variables, integers. I see a few of us circling unit rate. Look at all of these things that you already know about our lesson target today. I can tell that we're going to be incredibly successful. Who can tell me different ways that we model mathematics? Yes, ma'am.
Mine's from graphing, right?
Oh, beautiful. Graph. Yes, absolutely. Yes, ma'am. Table. Yes, table. We already have graphing. We have tables. What might be a third way? Yes, sir.
Function?
Can you be more specific about what you mean?
An equation?
Yes, perfect, an equation. So we have 3 different methods. Writing with me, please. We have an equation, a graph, and a table. Equation, graph, table. Today, we're going to see how many different ways we can model relationships between variables. But first, we're going to start off with this awesome girl named Lena and some pounds of coffee. Guys, okay, we're 8th graders, right? But who drinks coffee? Any of my 8th graders drink coffee? Yeah, absolutely. Always 8th graders drink coffee. But yeah, coffee is delicious, and apparently Lena really likes it because she went and bought 3 pounds, which personally I think is a lot, but whatever. That floats Lena's boat. I guess she's happy with her 3 pounds of coffee. So Lena paid $18 for this 3 pounds of coffee. I see 4 questions listed below my scenario around Lena and her coffee. When I say begin, you and your elbow partner are going to take 2 minutes to select which of those 4 questions you would like to focus on. And then I want you to show your work and your answer to that question in the space below. Now look at how large that space is. It's beautiful, right? I want you to fill it up with your thinking. So again, when I say begin, you and your elbow partner can choose which of those 4 questions you would like to focus on for these 2 minutes. You may begin.
Question one.
Alright. So how do we start? And then how many times?
3.
One side would be pounds.
So how many pounds of coffee did you buy for $1?
So we have to divide some of
So we have, if she's gonna buy a cup of coffee for $1, so how many pounds of coffee?
Is that when you do the proportional, like
Yeah, so now we're
at
talking
1 pound over something?
So we if she's paying $1,
So 3 pounds is $18.
she pays $16 or $18 for 3 pounds. So $6.
Then you're just working on questions.
That makes sense. Oh yeah, 1 pound costs $6. So then for $1 she could buy 1/6 of a pound. Is that right? Yeah. That's not. I didn't get that answer. Okay. Another way we can
Right. So this
Well, we multiplied all of them by 6, right? Yeah.
So if I just guess, if I just put one person, so at 3 pounds,
One pound of coffee
and you know
costs
it.
$6.
Coming back together in 5, 4, 3, 2, 1. If we could go ahead and put all of our eyes on Megan's work at the front, I just want you to take 15 silent solo seconds to take a look at her work. And I want you to think about her approach. Any thoughts about how she's representing the relationship here about Lita and her coffee? Yes, ma'am.
She's creating a proportion.
What do you mean? I don't. What does that word proportion mean?
Well, she's trying to show the relationship between the pounds and the amount.
Okay, so I hear something about like a proportion, the word relationship, like it's showing some sort of like correlation. Okay. Other thoughts on the work you see? Yes, ma'am.
I'm kind of confused as to how she, got to 6 without any work, like how she just plopped that down without showing anything, like how'd she get that 6, where that come from?
Good, so am I, right? If we show all this in front of a second grader, no way they're going to understand what's going on. Who can elaborate and help us get into the mind of Megan about how she might have determined that 3 pounds is $18, therefore 1 pound is $6? Yes, ma'am.
So if it was $18 for 3 pounds, and then her goal is to find out how much it is for 1 pound, you can sort of reason, so how do you get from 3 to 1? You would divide 3 by 3 and get 1. So then what I think she did is divide 18 by 3, and that's how she got 6, because what you do to one part of the fraction, you have to do to another. So divide both sides by 3, and that's how she got $6.
Okay, you want to elaborate, Cassandra?
Yeah, I remember learning about fractions that fractions are really like the division of the numerator by the denominator. So I'm seeing a relationship between like 18 divided by 3 is 6, and 6 divided by 1 is also 6. So that's why they're equal.
Okay, yeah, that like equivalency. So I heard a few things pop up. Is that 1, we were able to use division to solve, and then when we placed an emphasis on like finding this 1 pound or this singular unit for coffee. Taking a look at our second example, I want you to think about how this might be a little bit more clear for a second grader to understand as opposed to Megan's work here. So you see Betsy's work here with her table. And you see Megan's model here with her equation. I want you and your elbow partner to take 15 seconds to decide, would my table be a more useful resource for a second grader to understand a relationship? Or might my equation be more useful for a second grader to understand? 15 seconds, you may begin.
I think the table might be more useful for a second grader because they can see that the numbers on one side get smaller and the numbers on the other side get smaller. And I don't think they would know what fractions are.
So you're saying it's like going in descending order so you can see a pattern.
What about going across? I feel like there's patterns going across too, from 15 to 3, 12 to 2, 6 to 1.
3,
And it also says there's like
One.
a equation underneath too, not just the answer.
So what are your thoughts here? Yes, Michael.
There's an explanation underneath, not just the answer. Like the first one just had the answer. This one has like kind of explains what's going on above it.
Yeah, I noticed your group actually chose this third question to answer as well. How does your work differ from what you see here that Betsy did?
On our work, we didn't actually solve it. We were just answering the question, what representation would be helpful. But this person, I mean, I guess it wasn't. That wasn't part of the question. I changed my mind. Never mind.
We
You
made
can
a,
elaborate.
Well, because the question doesn't actually ask for you to answer it, the third one that we chose. So we didn't actually choose it. And but also like there's nothing to answer because it doesn't say the cost per pound really. I was just assuming that when I was reading.
Okay, so I see that here, even though Betsy, like it wasn't a specific question to answer, she was able to take some information and with her table formulate further data points that we might be able to use. But you guys actually had some more information on your paper besides just what Betsy had. What other models did you say that we could use to solve here?
Oh yeah, we chose a graph.
Okay, and someone in your group, could you elaborate on how you thought a graph might be helpful?
We just thought it would provide a visual representation to see that as one number got greater, another number did as well. As one number got smaller, another number got smaller.
Okay, so like sort of translating what we see here on our table, making it better for like a visual learner, absolutely. So we've actually just discussed 3 different ways that we could represent the relationship between Alina and her coffee. We have Megan's way with her equation. We have Betsy's way with her table and the explanation that Michael pointed out. And then we also have our third way we mentioned, which is a graph. But we still haven't come back to the question of which do you think might be most clear for a second grader to understand? Comparing again Betsy's work to Megan's. What do you think? Graciela. That's beautiful. Graciela.
The table, simply because it's organized. So if a second grader wanted to compare, the cost and the pounds are next to each other, so they can compare what the relationship is.
Yeah, absolutely. This gives me some multiple values here that I can reference that then maybe in group 1 I can actually reference for my table. Or excuse me, my graph. So you guys are actually going to take this to the next level. So if you'll go ahead and flip these to page 36. With your elbow partner, I want you to generate as many examples in the table of values using the known information or the graph that's provided. You'll go ahead and track your graph. And you need a silent college-ready hand for somebody that can tell me one thing that's missing from my graph. Yes, ma'am.
You didn't label your axes.
Okay, I didn't label my axes. So what might be a label here when you're turning and talking with your group member? I want you to think what might be a label for my X, what might be a label for my Y, but I'm missing something else as well. Yes, ma'am.
a title?
A title. So when you get to your independent practice and you're generating your own graphs, I want you to double check and make sure you have your X and Y axes labeled as well as your title. So with your elbow partner, you will have 2 minutes to complete your table, a well-labeled graph, and then think about the relationship between your table of values and the graph that you're now labeling. You have 2 minutes to begin with your elbow partner. You may begin.
So I label the y-axis cost, and then I label the x-axis pounds of coffee. Have a title.
It could be cost. I remember back, the dependent variable is always supposed to be an independent cost. So it's like the cost of coffee.
As a title, yeah.
By pound. The cost of coffee by pound.
So I have cost per pound.
How much are these? 2, 4, 6.
Where? These are each 2. This is 2, 4, 6.
Oh, you can see it.
Barely. And then 2 pounds of coffee, 2, 4, 6, 8, 10, 12.
Come on, guys, together in 5, 4, 3,
Here's the chart, I think, also.
2,
Oh.
1. If I were to ask you the cost for 10 pounds of coffee, how might you be able to use your table or your graph to find that answer? So if I were to ask you the cost of 10 pounds of coffee, how might you be able to use your table or your graph to find the answer? Let's hear from Rebecca.
So the first way I would probably do is just notice the trend in my table that every 1 pound of coffee, it's $6 more. So I would leave off where I was at 9 and add 1, 10, and then to 54, add 6 and get 60.
Okay, so interesting. So I hear you going to your table to analyze how, as one value on your x moves, you're analyzing, well, how does my y value move? And you picked it out of 6. You were like so forward thinking. We're actually going to get to discussing that method in just a few minutes. Awesome. Absolutely. So that's one method. How can I use this graph? Devin.
You have to extend the y-axis up a bit, and then maybe extend your line, and then figure out
So, if you have 1 pound of coffee, it costs you $6. If you have 2 pounds of coffee, it costs you $12. So you see that there's a common difference between 1 and 2 pounds, which is 6. So if you plotted those 2 points, 1 and 6 and 2 and 12, you can draw a straight line from that. So even if you didn't know what 10 was or 30 was, you can extend that line and you can draw your conclusion to where
And so,
where
what
that
would be my conclusion here?
at 10, 60.
Excellent job there.
F of x is 6x.
So that my 10 pounds of coffee winds up costing me $60. What I really appreciated about your more simple explanation was it allowed me as your teacher to better understand, like, can you explain this simply enough? And because you could, it allowed me to understand that, like, you really get what we're looking for today. So I'm definitely going to be show calling your work and looking for you to be a real leader, especially around using all the mathematical vocabulary you did. That was fantastic. So we've now discussed 2 different ways that we could find out missing values from our table, such as I could look at my graph or I could look at my table. On the count of 2, we are all going to respond to the following question. What would be the cost of 12 pounds of coffee? I'm going to give you like 5 silent solo seconds to think. On the count of 2, it will be a whole group response. What is the cost of 12 pounds of coffee? On 2. 1, 2.
72.
Oh, where are my units?
Oh.
1, 2.
$72.
Oh, nicely done. Excellent job. All right, so we're going to move right along, and we're going to dissect Lena and her 18 pounds, good lord, her 3 pounds of coffee for $18 a little bit further. But first, just like Roberto, just like he introduced us some more grown-up mathematical vocabulary, we're actually going to go through a few of the words he used together. So your pencil should be ready and writing. And we're going to go through our 3 new words: proportional relationship, infinite solutions, and unit rates together. As we have our College Ready Reader reading, please make sure that you are circling words that you are already familiar with and annotating using your Cubby strategies. So be a reader at proportional relationships, please. Sarah.
When you multiply your independent variable by a value, a constant of proportionality, and always find its related dependent value, the relationship is proportional. This means that 0, 0 will be a point on the line.
Please make sure that you underline 0, 0 will be a point on the line. This was a moment of confusion this morning during the Do Now, and I want you to make sure that we've got it clarified that 0, 0 is a point on the line in a proportional relationship. If you will be the reader starting at infinite solutions, please. Megan.
You can demonstrate more than one solution for 2 variables by modeling with a graph or equation. This represents all possible solutions.
So underlining graph or equation and all possible solutions. So Roberto hinted at that before with our graph representing like an infinite number of solutions. And finally, if you will be a reader at unit rates, please, Erin.
Answer is how many dependent units for one independent unit. This can be written in many ways for the answer. How many dollars for 1 pound, or dollars over pound?
Dollars per pound.
Dollars per pound. How fast were you driving? Speed in miles per hour or miles per hour?
Excellent reading. When I say go, you're going to have 1 silent solo minute to tell me how did Lena's scenario model our mathematical ideas and concepts. So how did her scenario model unit rates or infinite solutions, or a proportional relationship. I'm going to be looking for you to use those vocabulary words such as unit rate, graph, equation, models, etc. in your response. You have 1 minute. You may begin. Cassandra, could you go ahead and read your response for us?
Yeah, sure. We multiplied an independent variable, which was the number of pounds of coffee, by a value or constant of proportionality, which was 6, the price per pound, and always found its related dependent variable, which was the price of the coffee depending on how many pounds it was. That's all I wrote.
So Cassandra, what I really like that you're doing right there is you're pushing yourself to use some of the vocabulary that we learned not only like in prior grades and in science, but that we're really going to start using today, which was our independent and dependent variables. And I'm actually really impressed that you already assigned like our values to that. That was fantastic because that leads us perfectly into the next 3 types of models we're going to discuss. So if I'm approached, or I have a scenario model that I need to look at, first thing I'm going to do, right, I'm going to read the problem. So here it said, Lena paid $18 for 3 pounds of coffee. Okay, so I'm good to go, I read it, right? But then I'm actually going to do what Cassandra did for us already. I'm going to think, what is my independent variable, and what is my dependent variable? So I'm thinking, okay, independent, dependent. Like independent kind of acts on its own. So a simple definition, dependent sort of relies on that. I'm thinking that, okay, independent variable here will just be the pounds of coffee that I decide to buy. And my cost, actually exactly like Cassandra said, will depend on those pounds of coffee that I decide to buy. So I would go ahead and label my independent and dependent variable. So I like how Megan is taking notes with me and has actually used her Covey strategies to circle her pounds of coffee as her independent variable. And then she's like circled 18 and labeled it as cost as her dependent variable. So now I think, okay, I've got those identified. Now I want to find out how much would it cost for 1 pound of coffee. Because let's say like Lena, who is clearly obsessed with coffee, and maybe like her grandparents or something come over for coffee on the weekend, like it must be genetic or something, so clearly she's gonna have to buy some more coffee. So she's gonna have to figure out, well, if I have to go buy 7 pounds of coffee to make my family happy this weekend, how much is it actually gonna cost me? So to determine that, I'm like, okay, I need to find my unit rate, or the cost for a single unit or a pound of coffee. So then I'm thinking $18 for 3 pounds. All right, I gotta get it down to 1 pound. Well, 3 divided by 3 gives me that 1 pound. So if I split $18 amongst those 3 equal pounds, that gives me $6 per pound. So it makes it a lot easier for Lena when she's going to Starbucks or wherever knows who to buy this ridiculous 5 pounds of coffee for her grandparents this weekend. How much would those 5 pounds of coffee cost, please? Sarah.
$30.
How do you know?
I multiplied 6 by 5.
Why?
Because 1 pound is $6, so 5 pounds would be $6 times those 5 pounds.
Okay, I want you to rework your explanation and include the new word unit rate.
The unit rate of the cost of coffee would be 1 pound per dollar, per $6. So then 5 pounds would be $30 because they're proportional.
Okay, and just be careful with your language. It would be $6 per pound, but nicely said, and good job using your unit rate there. So now that I've analyzed my scenario and I found out my unit rate, I feel like I'm pretty good to go. I determined how much it costs for 1 pound of coffee. So now I think, okay, I can jump into a table model. What is kind of awesome about a table model is it can represent a variety of solutions. let's say I'm not always given my unit rate. Like this graph, so easy, a little bit ridiculous. It already tells me my unit rate. It says 1 pound of coffee is $6. Easy peasy lemon squeezy. Let's say that it wasn't so easy. We actually already had this introduced. Rebecca, do you think you could walk us through again how you determined the unit rate value based on the table we had analyzed from Betsy's work?
Sure. So I noticed that our independent variable, pounds, every time it increased by 1, our dependent variable, the cost, increased by 6.
Fantastic.
Okay.
It's as simple as that. You did a great job, yeah. As my pounds or my X value increases by 1 unit, I want to see, well, what is the increase for my Y value? And just like Rebecca said, it increases by 6. So for every X value increase of 1, I can see that Y increases by 6, meaning my unit rate would be 6, and in this case, $6. Excellent job, Rebecca, on your forward thinking there. All right, table, scenario,